Before starting to talk, we should talk about two main challenges in wireless and mobile networks. There is a big difference between a wireless network, and mobility. Wireless is not mobility. Okay? When we talk about wireless means a communication link that I can use it to make a connection, for example, to a BTS, to connect to internet. In other words, wireless means communicating over a wireless link. But when I'm talking about mobility means that a mobile user, a user who can move from one network to another network, leaving an access point and attaching to another access point while it's communicating. Okay, maybe communicating, maybe yes, maybe no. For example, when I'm moving from Najaf to Karbala, my cell phone is in my pocket, and during this journey, during this travel, moving from Najaf to Karbala, during this travel, my cell phone is mobile. It moves from Najaf network to Karbala network. So wireless is something different from mobility. And by the way, in this chapter, we will talk about these two challenges. We will talk about wireless and definition of wireless and definition of mobility, and some related materials and topics around these two main categories, main challenges. Okay. So maybe the first question is this: what are the elements of a wireless network? Look at this picture here in slide 4. I can see there are several blue clouds in this network, in this picture. In the center of those blue clouds, those blue circles, you can see there is a spatial antenna or base station. We talked about base station in chapter 1. Okay. At the center of those blue circles, we can see there is a base station where that base station is connected to the wired infrastructure, wired network infrastructure. Okay, and you can see some of those blue circles are bigger than the rest. Some of them are big and some of them are small. Okay. Let me talk about the elements more clearly. The first element is a wireless host. A laptop, a smartphone, and a wireless IoT sensor, I don't know. A wireless host is a system which runs which run a network application, and maybe this host is stationary and maybe it's mobile. Please be clear, when we talk about a wireless host, it doesn't mean that my wireless host is a mobile host. There's a big difference between them. Maybe my host is stationary, but it's wireless. And maybe my host is mobile and it's wireless. So wireless does not mean mobility. There are two different terms. We should be clear when we talked about them. Okay, maybe sometimes a wireless host is mobile, and maybe sometimes not. It's not. Okay. The second element in these networks is base station. Base station is an antenna mounted on top of a tower. Okay, and from one side in my network, my wireless hosts are connected to the base station, and in the other side, the base station is connected to the backbone of internet, to other areas, to other networks. Mostly, the base stations are connected to wire infrastructures, mostly, but sometimes they are connected through a wireless backbone. For example, I have an antenna in a desert, in a big desert. Okay, I know that the cost of optical fiber cables is high. So instead of deploying a fiber cable infrastructure, just simply I'm using a wireless backbone. Okay, with directional antennas, I can use them. You can see this strategy when you are moving from one city to another city. Okay, so we have a base station. It connects me. I'm connecting using a wireless link to the base station, and then that base station connects me to the rest of internet through a backbone, mostly a wired backbone. So I can say the base station is a relay. It's responsible for sending packet from inside a wireless network to the internet, or sending packet, receiving packet from internet and sending it inside my network. Okay, and as I talk in chapter 1, this base station is a general name. Its naming is different in different wireless networks. For example, in Wi-Fi or standard IEEE 802.11, we called it access point or AP. In cellular network, we called it BTS. In WiMAX, we called it base station. So here, when we talked about base station, it's a general name. And the last element was wireless link. That we use wireless link to connect hosts, wireless hosts, to a base station. Then, as I said, sometimes I'm using wireless backbones to connect a base station to other networks in the internet. Okay, and when I'm talking about a wireless link, I should mention that we have several types of wireless links with different specifications. Each wireless link has its own transmission rate, has its own channel and bandwidth. Its communication range is different from one network to another one. So they are completely different. For example, here in this figure, you can see that in a wireless network, I'm using a frequency band of 2.4 gigahertz. And this frequency bands wireless wireless channel has only 30 feet communication range. Okay, so it's easy for me to so its communication range is limited to 300, something like that, 30 meters, excuse me. But when I'm talking about, for example, a 4G network, a 5G network, a cellular network, maybe its communication range is extended to 15 kilometers, maybe 20, 25, and maybe more than this, 30 or 40 kilometers. Okay, so they are different. They are completely different. So we should be clear about those wireless net links specifications. Here in this figure, we can see this. Here, you can see different values for the range of those wireless links. Some wireless links are indoors, some of them are outdoors, some of them mid-range outdoors, and some of them are long-range outdoors. Indoors means that a wireless network which is used inside a building. And outdoors means that I'm using a wireless network outside of buildings. When we talk about indoor localization, indoor wireless networks, we talked about very small ranges of communication. For example, Bluetooth technology can send information just into 5 to 10 meters around itself. In Wi-Fi technology, we can see that inside the building, its communication range is only, for example, 30 meters, just a few meters. Okay, but when we use Wi-Fi technologies outside of the building, we can see its communication range would be expanded to, for example, 100 meters. In 5G, the communication range is about something near to 4 kilometers, and in 5G, in 4G, this communication range is more than 4 kilometers, maybe 15 or more than 15 or more. 15 kilometers. But here you can see, for example, the Bluetooth technology has only 2 megabit per second communication range, but in 5G technology, we can see the speed or the transmission range is 10 gigabit per second. Or in LTE, the transmission range is near to for example, 400 or 500 megabit per second. something like that. Okay. So when we use wireless link, we have to be care about the properties of that wireless link. Let me mention that here we have not. Okay, we have more wireless links too. They are not mentioned here. For example, instead of Bluetooth, we have another technology called it Zigbee. It's similar to Bluetooth. Or, for example, if I want to make a wireless communication in a wide area, as a wide area, a wireless network, but with a small, very small transmission rate, I can use LoRa technology. Instead of using this technology, I can use LoRa technology. Okay? So there are some other techniques here. For example, WiMAX. You cannot see the WiMAX technology here. But in this book, in this course, we don't talk about Zigbee, LoRa, or something else. We just talk about Bluetooth, Wi-Fi, and cellular networks. Okay. Okay. When we talk about a wireless network, we can divide a wireless network into two groups according to its mode. A wireless network may or may not have an infrastructure. Infrastructure means that there is a tools that I connect a wireless network into a wired one. Okay. So I can group wireless networks into two main groups: infrastructure mode and ad hoc mode. When I'm talking about infrastructure mode, I'm talking about some wireless networks who has a base station in their hearts, and the wireless host in that network are connected to the internet through the access point, through the base station, through the infrastructure. So that infrastructure makes a way, a pass, a channel from inside my wireless network into the internet. Okay? Into the internet. So this mode is dependent on the infrastructure. When mostly we use this structure. For example, if in my home I have an access point. I'm connecting to the internet through that access point. So I'm using an infrastructure mode wireless LAN or Wi-Fi, or I'm connecting to a 4G or a 3G or 4G cell phone tower. So it's an infrastructure mode network. But there is one main term, one main phrase in infrastructure mode networks. We call it hand off or handover. Okay? What is handoff or handover? Handoff or handover means that I'm connecting to a wireless to an infrastructure, and while I'm connecting to that infrastructure, I'm moving from one network to another network. So I have to change my base station to a new one in the new network. We call it handoff or handover. Changing the base station while I'm connecting to internet. Look at this. Why? I'm connecting to the internet. It means that during the handoff or handover, I must not disconnect the connection. I should keep the connection while I'm doing handoff. Okay, I must keep the connection. The other mode is ad hoc mode. What does it mean? In ad hoc mode, we have not base station. There is no base station in my network. So, each network can only transmit its information to its network, to its neighbors. Neighbors means a system who is standing in the communication range of my system. Okay? In infrastructure mode, when I try to send information, I have to send information to the base station. And then that information will be sent through the access point or through the base station toward the final destination. But in ad hoc mode, we have no access point for infrastructure. Okay? So in ad hoc mode, the only way to communicate with the other systems is that I have to use the communication capabilities of other nodes in my network. It means that the wireless nodes in an ad hoc network acts as a relay, acts as a separated wireless router. While they are sending information, they have to forward the packets belongs to other nodes of the ad hoc network. So I can say, okay, there is a self-organized network. Yes, the ad hoc network is a self-organized network. It means that they should find a route between themselves, between the nodes in the ad hoc mode, finding the route between themselves and forwarding the packet to that route. Ad hoc is a special as an interesting types of network, types of wireless network. For example, you can use ad hoc networks in SOS teams, in military zones, between military teams. When an earthquake happens, flooding happens, and something like that. Okay? For example, when an earthquake happens, a fire happens, this fire or earthquake will destroy everything, every infrastructure. So I have no infrastructure. Or a military team. For example, there are some UAVs in the sky, some RXs, some jet fighters in the sky, some helicopters, some tanks on the ground, some troops and fighters on the ground, and they made an ad hoc network and communicate together. This is an ad hoc network. Or an SOS team, firefighting station teams. they need to communicate together. So they need to make an ad hoc network between themselves and communicating to each other through using that networks. Okay. So I can divide my wireless network into 4 groups. Have they infrastructure, yes or no? And are they single hub or multi-hub? There are 4 different groups. The first and most widely deployed types of wireless network is a single hub wireless network with infrastructure. Something like Wi-Fi. When I'm connecting to the access point of Wi-Fi or in cellular network. Okay. The communication is single hub and I'm communicating through infrastructure. For example, through an access point. But I can have an infrastructure and at the same time using multiple hub communications, for example, in a mesh network. There are several infrastructures and the wireless host should send the informations through different hubs toward that infrastructure. And I can have some special networks who have not infrastructure. A single hub wireless network without infrastructure is, for example, Bluetooth or ad hoc network. Okay, some of ad hoc networks, but Bluetooth. When I'm using Bluetooth, there is no infrastructure, and I have sent information directly to another host near myself. The communication range of Bluetooth is something between 5 to 7 or at most 10 meters, not more. So Bluetooth is an ad hoc single hub wireless network. But we can have an ad hoc mode with multi-hub, a multi-hub ad hoc network. Okay, and there are some special types of ad hoc networks, multi-hub ad hoc networks. We call them MANET and VANET. What is MANET? MANET is standing for mobile ad hoc networks. It's a special type of ad hoc networks. Okay, in ad hoc network, we never talk about mobility of nodes, but in MANET, all the nodes, most of the nodes are mobile, and in VANET, the nodes are vehicles. What does it mean? It means that I have some vehicles running on the street, and for example, I'm driving in the street and I'm seeing an obstacle pushing the braking pedal. The driver behind me should see the red lights of my car and process that image in his mind and decided, okay, I should push brake too. Brake pedal too. Okay. We call this time as perception and reaction time. Watching is seeing that red lights, processing and making, for example, pushing the brake pedal. This perception and reaction time is a number is at least 0.2 or 0.3 or on average 0.5, half of second time. But for example, for some peoples, for example, sleepy people or drugged people, or people who use who drinks, the perception and reaction time is near to 1 second, and it's dangerous according to its speed. So the basic functionality of the basic goal of VANET is improving the safety inside the roads. When I'm pushing the brake pedal, the VANET technology detects this pushing and it sends information to the other cars along my street, and they can automatically decide about what they can do very fast. So by using VANET, we can decrease the amount of accidents, car accidents in the roads. Okay. Next topic is wireless link characteristics. There are some main differences, some important differences between a wireless link and a wired link. Here we talked about some of those differences. The first one is that although in a wired link we have a decrease in signal strength, in power of signals, but this decrease in wireless networks is much bigger than wired networks. Why? Because in a wired network, my signals are guided in a restricted area inside the area. But when I'm using a wireless link, I'm sending my signals inside a big area, big space. So my signals will lose its power sooner and more than signals inside cable network, a wired network. So we have pass loss or decrease in signal strength faster than the signal strength decreasing in signal strength in wired networks. The second difference is that in wireless network we have several interferences. Why? Because in a wired network I have a wire which is under my control. I can control it completely. But in wireless network, I'm using air as a medium of my network. I cannot control the air. Why? For example, in Wi-Fi, we are using 2.4 gigahertz and channels. Okay, and as I know, there are several other devices who are using these channels. There are too many devices who are using these channels. Okay, so simply they interfere with each other. It means that I'm sending an information in a channel and someone else sends another information in the same channel, and at the receiver will receive the summation of these two signals. Summation of these two signals. Okay. So interference is something common in wireless networks, and I cannot control it. The other difference between a wired and a wireless network is that in wired network, my signals have to propagate it along the cable. They are under control. They have only one pass in the network, moving toward the destination. But in a wireless network, I'm using the air, and there is no specific pass. Maybe someone say, okay, you can use directional antenna. Okay, yes, I can use, but still, my signal has different passes toward the destination. One of maybe some signals can move directly toward the destination, and some signals reflect by some sources along the path, and then after that receive to the final destination. This effect, multipass propagation, is a negative effect. It can destroy my signals. It's something like interference. Okay. So I can say that making a wireless connection is much harder than making a wired connection. Okay. Let me show you another characteristics another character in wireless network. We have a special criteria. We call it SNR, or signal to noise ratio. SNR means that how much my signal, the power of my signal, how much is higher than the power of noise in my network. Noises are some signals, some bad signals in my network. I cannot control them, okay? So, if I want to detect correctly my signal at the destination, I have to use more powerful signals. Because as soon as my SNR value becomes larger, I can detect the signals more easily. So maybe someone said, okay, why you don't use, why you are worried about this? You can use more power when you are sending information, sending signals over a wireless network. No, it's not correct. You cannot increase this power as much as you want. There are several negative effects on live bodies. Those powerful signals are dangerous for planets, for trees, for animals, for humans. It's not a good option. Never think about powerful signals. They are very dangerous for all lives. Maybe they make different types of cancer in the bodies. Okay, so we have to reach to some special level of SNRs to extract the primary signals at the destination from the noises. Okay. The SNR has a reverse relation with bit error rate, or BER. What is BER, or bit error rate? Bit error rate means that how much of my information are are not corrected at the receiver, are destroyed when they are moving along the path, along the wireless link toward destination. How much of send information are destroyed, are corrupted during this path? Okay, we call it bit error rate. And as we know, bit error rate is a negative parameter. SNR has a reverse relation with bit error rate. It means that if I increase the output power, I will increase the SNR, so my bit error rate would be decreased. But as I said, this strategy is not good most of times. It's not good. It's not a good strategy because of its bad effects. Okay. So there are other methods to control these values, SNR and bit error rate, especially in current networks. We use modulation techniques. For example, here you can see three different modulation techniques: CAM 256, CAM 16, and CAM BPSK. And you can see the transmission range, the transmission rate of these modulation techniques. Okay. Look at this chart here. I'm starting with a predefined SNR value, and as long as this value decreases, we can see the bit error rate would increase. So after a while, I should change, for example, my modulation technique from CAM 256 to CAM 16, and after that, changing it to BPSK. It means that because of bit error rates, higher bit error rate values in my network, I'm using more stronger modulation techniques in my network to defy the bit error rates, to defy the errors or noises in my network. Okay? There is one more other characteristics in wireless network. Look at this figure in the left side of slide 15. We have three nodes, A, B, and C here, and there is an obstacle between A and C. They are close. A and C are close together, but there is an obstacle between them. So A and C cannot see each other because of that obstacle. Okay? In this case, A and C cannot see each other, so they are hide from each other. They are hide. And what is the problem? The problem here is that A and C cannot see each other, so maybe they decided to send information to B at the same time. And now I said that if I send information at the same time at the receiver will receive a summation of those signals, which it means that the received signal is corrupted. Here we call it hidden terminal problem or hidden node problem. A and C cannot see each other because of the obstacle. So if they send information to B at the same time, the B cannot receive those information correctly. The B will receive those information, the summation of those information, which is corrupted. Another type of hidden node problem or hidden terminal problem is the figure on the right. Here, in the right figure, I cannot see an obstacle, but A and C are far from each other. Okay. At the same time, and C, at this time, A and C again cannot see each other, but B can see him. Because look at this curve line, these curves, blue curve and red curve in this chart here. You can see after a while, this curve is signal strength or the power of signal, SNR value. Okay, SNR is a portion of this signal strength. You can see that this strength, after a while, after specific distances, this signal, the strength of this signal, the power of this signal is decreased very fast. There's a collapse. You can see there's a collapse in signal strength. And C can hear a very weak signal of A. In a similar manner, A can see a very weak signal of C. But as I said in the past, a receiver only can receive signals that have a minimum level of energy, a minimum level of strength. If the strength of the received signal is lower than a predefined threshold, the receiver cannot receive them, cannot hear them. For example, in earthquake, we can see there are different dikes. The SOS teams bring dikes to the earthquake zone. Okay, why? Because the dike, because of having larger areas, the dike's air can hear weaker sounds. So here, again, in this case, A and C cannot hear each other because they receive a very weak signals from the other side. So they cannot we cannot see each other. So again, you are hide from them perspective. Okay. Okay, maybe someone said that, okay, is there any solution to solve this problem? It's good. If I have a channel and I have a shared channel, and if I send a signal, a packet through this channel at the same time with the other users in the channel, the result signal would be affected. It will be corrupted. Is there any solution to solve this problem? If someone asks me this question, I will say, oh yes, there are several solutions. One of the best solutions in this case is using code division multiple access or CDMA technology. In CDMA technology, firstly, I'm assigning a unique code and a specific code to each of the users in the network. This is a unique code. And then, when the user tries to send information over the network, firstly, it should times its code with its data, and then send the result information. It means that I'm applying an encoding technique. It's something similar to encryption, something like that. It's not an encryption, okay? It's not an encryption, but it's something near to encryption technique. So each user have to times its code to its data, and then the result would be sent over the network. In the other side, at the receiver, again, the receiver can times the code with the received information. Using this way, it can extract the original data. Look at this example here. Let me, okay, this one. Here, I have two data. Okay, with one single code. This is the code. You can see it's repeated for both of those data. The first data is +1 and the second data is -1. Okay, and I have a predefined code, a unique code. Okay, just simply adding and timesing this data into this code. Look at the result here. There are two separated data. Just simply times this data into this code. You can receive to this data. And I will send the data into the toward the receiver along the wireless channel. Okay, at the receiver, look at this one. At the receiver, again, I'm timesing the result with the code. And then, look at this one here, this equation. I'm timesing bit by bit the code with the data. And then I'm finding their summation, dividing by m. What is m? M is number of bits in this code. In this code, yes, we have 8 bits. So simply, for example, here, 1 times in 1. Here, 1 times in -1. 1 in -1. 1 in -1. -1, -1. 1. 1 minus 1. -1, 1. -1, 1. -1, 1. So the result is -8 summation. We have 8 minus 1. If I find their summation is -8. So simply, -8 divided by 8 is equal to -1. It's simple. However, it uses lots of power to times this code into the original data and then sending information toward the network, and at the receiver again I should times the code in the received information and then finding the summation and then dividing. It's too time consuming and it needs too much power. So this strategy never proposed by the researcher for those networks who has limited powers. For example, in wireless sensor networks. Okay, this strategy is not good. But mostly we use this strategy in cell phone networks, in 3G, 4G, maybe in 5G networks. We use in some types of 3G, 4G, or 5G strategies. We use this technique, CDMA technique, not in all of them. Okay, just in some of those techniques we use this strategy. Okay, maybe someone say that okay, this is a simple. This is a simple example, but show me a bigger example. What will happen if I have two users sending information at the same time? Okay, this is another example. Here, I have two users with two different codes. Those codes are completely Unix. Okay. Again, they times their code into their data and sending it over the internet, over the network. But look at this here. What will happen inside the network? Because those signals have similar frequency over the network, I can see a summation of those signals because they have similar frequencies. Okay, so I can see a summation of those signals. And what will happen at the receiver? At the receiver, I receive this code. Again, just simply, I'm applying, for example, code of sender 1 into the received data. Same as the previous. Just same as the previous. I timesing this code into the received data. It's not, I'm not care about the received data. Okay, just simply I times the received data into the code. And look at the result. That is interesting. The result is interesting. I repeat the primary data at the receiver. Two senders, sender 1 and 2, sends information simultaneously on a similar frequency at the same time over a similar channel with different codes, different Unicodes. And at the receiver, I extract the result. I recreate the result at the receiver side. Wow, that's interesting. How can I do this? Everything is about the code. Those codes are orthogonal. Orthogonal means that, for example, in a 3D environment, the vector x and y and z are orthogonal. If, for example, you stand on vector x and look on vector y, you can see vector x is something like a point over vector y and z. And if you stand over vector z, you can see, okay, vector z is similar to a point over vector x and y. Why? Because they are orthogonal. Their shadow is something like a point over each other. In CDMA, we use this strategy. But we need to find a strategy to create those codes. If you like, you can read more about those codes and how to find those codes. In new generations of cell phones, we can see the researchers try to improve this CDNA strategy. Because, as I said, this strategy uses lots of power. However, this strategy is very interesting for us, but it uses lots of power. So researchers try to solve this problem and or replacing it with something else, and we will return to this discussion in the future of this chapter, inshallah. Is there any question? Any question? Okay. I wish the best for you in the rest of this day, and goodbye.